Okay, these are notes 5, 8. For your warm-up, you're supposed to simplify the trig expression into just one trig term. The first thing I did is I took this and went ahead and multiplied those two signs together to get sine squared over cosine. At the same time, I went ahead and saw that I still had cosine in the denominator. So I made this term have a same denominator. When you have two terms, you want to try to combine it into one term in some way, shape, or form. So that was cosine times cosine, where I got my cosine squared, and that's going to be over cosine. This was sine squared over cosine, create one fraction. So that's a Pythagorean identity, and these are my Pythagorean identities that I wrote out up at the top. That's 1 over cosine, which is the same as secant. We would prefer everything in terms of sine and cosine, unless that means sine or cosine's in the denominator. Then we would go ahead and put the reciprocal identity in. The next one is a little bit more involved with your fraction, but it's not too crazy. I chose just to focus on this to begin with. I saw that I had two terms down there, and I went ahead and I created one. So this is a quotient identity here, and another quotient identity, tangent into sine over cosine, cotangent into cosine over sine. What I decided to do is take those two terms, combine them into one. So I created a common denominator, and the common denominator is going to be sine times cosine. Not pretty, but it's going to get the job done. That becomes sine squared plus cosine squared, all over sine times cosine. And then that's 1 over sine times cosine. And this is just the denominator that I went through and I simplified. So once I have that simplified, I rewrote this entire expression as this in blue. So tangent went into sine over cosine, and the denominator I replaced with 1 over sine times cosine. Dividing a fraction by a fraction, so you multiply by the reciprocal of your denominator. So sine over cosine times cosine over 1. Your cosines cancel. Sine times sine is sine squared. That would be the simplified version. And then from there, list the 6 trig functions and the respective reciprocals, which is probably from your notes or from your Pythagorean identity sheet. Just make sure they're written down, make sure they're correct, and make sure that you kind of have them going both directions. What we're going to work with today are trig equations with reciprocal identities. Now, I'm not big on memorizing all the trig values for what's cosecant of 45 or what's secant of 60. Typically, I think the ones that you really need to have memorized, so we do a little chart, sine, cosine, tangent. You really need to have your 30, your 60, and your 45, and from there we can pretty much figure everything out. So if you don't remember this, maybe jot this down very quickly in your notes as well, but we're going to be using these trig values, and I think you have a nice little chart yesterday in your notes as well. So if you have these, you're pretty much going to be good to go, but we want to make sure that you at least know sine, cosine, and tangent. The reciprocal of sine is cosecant, reciprocal of cosine is secant, and reciprocal of tangent is cotangent. So we just want to make sure we know where our reciprocals and the trig stuff for our 30s, our 45, and our 60. From here, what we're going to do is we're going to solve the following equations on an interval from negative infinity to positive infinity. And we're going to have reciprocals. There's going to be a little bit more work, but nothing's going to be too crazy. Typically, we really like when we are just on a closed interval because we have a set number of answers. When we go to positive, negative infinity, that just means now I can keep rotating around that unit circle and have an infinite number of answers, essentially. Just like what we did yesterday, you want to make sure that you isolate that trig expression. So you're going to get secant squared equals 2. This is like your variable, so go ahead and square root each side. So secant of x equals plus or minus radical 2. Now from here, this is typically what I do. Instead of trying to memorize secant, cosecant, and cotangent values, I think about reciprocals. So the reciprocal of secant is cosine. And then the reciprocal of radical 2 is 1 over radical 2. And if we rationalize that, we get radical 2 over 2. Don't forget your plus or minus. So another way of thinking about this secant mess is thinking, okay, well, I'm going to look at it in terms of the reciprocal. So where is cosine plus or minus radical 2. That would be a 45-degree reference angle. All students take calculus. In this case, we want the positive and the negative version, so we're going to do every single 45 on our unit circle. So that's going to be pi over 4. The next one should be 3 pi over 4, 5 pi over 4, and then 7 pi over 4. That would be for one rotation around the unit circle. So that's going to be the answers if I'm looking at this guy. It's going to give me those 4 answers. However, we're going to go, so it would be one rotation around. We're going to keep rotating and rotating and rotating. So what we're going to say, each time around the unit circle is one trip around times k being your number of trips. So all of these guys, when we're on the positive to negative infinity interval, we just say, okay, well, this one's going to have another trip around. Maybe we're going to take 2 trips around or 3 trips around. That's how we'll find the corresponding or coterminal angle that would go with that. Cotangent squared plus cosecant equals 1. Now this one is not exactly going to be pretty at all. And that's because you have this cotangent squared and you have this cosecant hanging out as well. So what I would suggest doing is looking at your Pythagorean identities and maybe finding a nice substitution. I would focus on the one that's being squared. So let's write these guys out and see if I can get the one that's being squared kind of out or replace it with something. So this is a general one that I suggest that you memorize, and we want the one that's going to have cotangent in it. Cotangent would be cosine in the top, which means we divided everything else by sine squared. So the Pythagorean identity with cotangent is going to be 1 plus cotangent squared of x equals, and then we're thinking about reciprocals again. So this is 1 over sine squared, so that's going to be cosecant squared of x. Now we have this guy that we want to replace, so we're going to isolate cotangent. So it's cosecant squared of x minus 1, and that's going to go in over here. So this guy's going to come out. Cosecant squared of x minus 1 plus cosecant of x equals 1. From here, what we're going to do, let's go ahead and add 1 to each side, maybe? Probably not. Because I have this guy being squared, let's think about factoring, so let's subtract 1 from each side. So cosecant squared of x plus cosecant of x minus 2 equals 0. If you want to, we can go ahead and factor this. So let's see here, we're going to have a negative 2. We need to add up to 1, so 2 and negative 1. So w squared minus, plus 2. This should be squared. W minus 1. So it's going to be cosecant of x plus 2. Cosecant of x minus 1. Cosecant of x equals negative 2. Cosecant of x equals 1. Lovely, but that is what that bad boy factors down into. Okay, so then we have these 2 factored down, and now we got to think about reciprocals again. So the reciprocal of cosecant, we're going to think about sine, and the reciprocal of negative 2 would be negative 1/2. So we're thinking about where is sine equal to negative 1/2. That is going to put us into the 3rd and 4th quadrants. That's where sine is negative. All students take calculus. And we have negative 1/2. Well, that should make you think about a 30-degree reference angle. So the ones that are closest to the x-axis. That should happen at 7 pi over 6 and 11 pi over 6. Those are our 2 30-degree guys. Same with this one. So reciprocal is sine. Reciprocal of 1 is 1. Where is sine equal to 1? So that's going to happen at this spot right here. Pi over 2.